Let's study oblique asymptotes. So this is curve in terms of xy or fxy equal to 0. And we assume that y equal to mx plus c is an asymptote. At point P, the coordinates are xy, and we draw perpendicular on this asymptote. So we can find the length PL. We know that distance of a line, suppose y equal to mx plus c, and point is suppose x1, y1, then perpendicular distance can be found by formula d equal to, we replace here x by x1 and y by y1. So we write modulus of y minus mx1 minus c divided by root of square of coefficient of sum of squares of coefficient of x and y, 1 plus m squared. The same concept we are going to make use here. So we write PL, which is perpendicular distance, will be y minus mx minus c divided by root of 1 plus m square, or we can cross multiply PL multiplied by root of 1 plus m square equal to y minus mx minus c. If we divide each term by x, so we will get PL upon x times 1 plus m square equal to y upon x minus m minus c upon x. Now we assume that this line, this curve meets its asymptote at infinity. So we can say when x and y approaches to infinity, in that case, this length becomes 0. Then PL tends to 0. So again, we proceed from here. So limit x tends to infinity, and same thing we write PL divided by x root 1 plus m square equal to limit x tends to infinity y upon x minus m minus c upon x. So here, as I told you, that at infinity, this perpendicular length will become 0. So LHS will become 0. In RHS, we will get limit y tends to 0. Sorry, not y, but x tends to 0. Y upon x minus m, because this term you can take 0. So we can say that m equals limit x tends to infinity y upon x. So this is equation number 1. Now, again, from here, we can write the relation. We can take C to LHS, and then we can further write limit x tends to infinity, this y minus mx equal to limit x tends to infinity, then PL will tend to 0, and then this all thing plus C. So PL into root of 1 plus m square plus c. Now further, limit x tends to infinity, and since PL is tending to 0, so only c will be left, and here y minus mx equal to c. So we have got the condition that if y equal to mx plus c is an oblique asymptote, then m equal to limit x tends to infinity y upon x, and c equals limit x tends to infinity y minus mx. Let's understand it through an example. So question is, find the asymptote for y equal to x e power x minus e power minus x divided by e power x plus e power minus x. Now, first of all, we have to check whether there are asymptotes parallel to x and y axis. So clearly, y does not tends to infinity for any value of x. Here, finite value of for any finite value of x. So we can say there is no asymptote parallel to y-axis. Now, we have to assume that asymptote which is not parallel to y-axis is y equal to mx plus c. It means we are assuming that there is or there are oblique asymptotes. So let's determine. We know we have already proved that m equal to limit x tends to infinity y upon x. So from here, if we find y upon x, so we will be left with e power x minus e power minus x divided by e power x plus e power minus x. So limit x tends to infinity e power x minus e power minus x divided by e power x plus e power minus x. We can divide each term by e power minus x. So we will get limit x tends to infinity e power. Sorry, we have to divide by e power x. It will be better. So then first term will become 1. Second term will become e power minus 2x divided by this will become 1. And this term will become e power minus 2x. And when we put x equal to infinity here, so we will get its value 1. So we have got the value of m as 1. Now to determine c, the formula is c equal to limit x tends to infinity y minus mx. Since m is 1, so limit x tends to infinity y minus x. So y is this. We can write it limit x tends to infinity x e power x minus e power minus x divided by e power x plus e power minus x minus x. Now, we further simplify it. So it will become c equal to limit x tends to infinity. We take LCM. So LCM will be e power x plus e power minus x. Then here x will get multiplied to both terms. X e power x minus x e power minus x minus when x is multiplied with these two terms, it will become x e power x minus x e power minus x. Now, from here, this term and this term will cancel out. So we will get a limit x tends to infinity minus 2x e power x with a negative sign divided by e power x plus e power minus x. Now, if we further divide by e power minus x, or we multiply each term by e power x. So if we multiply each term by e power x, we will get c equal to limit x tends to infinity, and this will become minus 2x divided by e power 2x plus 1. Now, if we put x equal to infinity, we will get infinity upon infinity. So this is not suitable. So it is better to apply L'Hospital rule. So L'Hospital rule says if we are given yx upon gx, so we can differentiate, we can write y dash x divided by g dash x with same limits. So here we can write it as c equal to limit x tends to infinity, we differentiate it. So this will become minus 2, and this will become twice of e power 2x. Differentiation of 1 will be 0. So this will become minus 1 upon e to the power, and when we put x equal to infinity, this will become infinity. This will be minus 1 upon infinity, which will give 0. So we have got m equal to 1 and c equal to 0. Thus, we can say from y equal to mx plus c, we have got the asymptote y equal to x. So this was the case when we have applied the limit x equal to infinity. When limit x is tending to minus infinity, in that case, we will get m equal to minus 1 and c equal to 0. Thereby, we will get the asymptote as y equal to minus x. So we have got two asymptotes, and the same can be graphed. So let's draw the graph also. So graph will be this is y-axis, and two asymptotes are there. So we can draw the asymptotes, then we will draw the curve. This will be y equal to x, this is y equal to minus x. And then there are curves. The curves are like this. These asymptotes will touch the curve at infinity. Similarly, here there is curve. This is y equal to x, this is y equal to minus x, and this is x-axis, this is y-axis. Thank you for watching.